Hello class 8. In the last class we had learned about biometric strip. So today an application of biometric strip we will discuss. The automatic fire alarm. You must have heard about this fire alarms. What does a fire alarm do? If there is a fire in the room, then the alarm goes out in the house. Okay, it will warn the inhabitants of the house that there is a fire. So how does the fire alarm work? Something has to be there which triggers the alarm. So we use a biometric strip as the trigger. Okay. Now here is how a biometric strip automatic fire alarm looks like. This is the biometric strip. The shaded region is made up of one metal, and the unshaded region that I have drawn here, it represents another metal. Alright, so the shaded region may be the metal with the lower heat expansion, and the unshaded one, the lower metal, it will represent the higher expansion metal, the metal which expands more. Remember, fire alarm, one of the metal expands more, one of the metal expands less. So that principle we apply in a biometric strip. So like that, the upper one is having low expansion coefficient and the down one high expansion coefficient. So like that, this is the this is the biometric strip. This is the point of contact, and this is the circuit which is powered by a battery, okay, or any low voltage power supply. So this powers this circuit. This circuit is connected to a bell. Okay, there is a bell holder which on top of which there is a bell mounted. This is the hammer which rings the bell. So as you can see right now, the circuit is incomplete because there is a gap between this point of contact and the biometric strip. So the bell will not ring. When the bell will ring, it will only ring when there is contact between these 2 points. This point touches this point, then only the current will start flowing through the circuit, and that current will make the bell to ring. So how will that happen? For that, we need to bend this bimetallic strip. And how will that happen? It will happen when we supply heat. If there is a source of heat like fire, okay, heat by fire. So when the room gets heated up, and this fire alarms are located on the top near the ceiling of the house. So when the heat from the fire goes to this automatic fire alarm, it will give the biometric strip. Biometric strip will bend, as we know, okay, because of the uneven coefficient of expansion of the two metals. The metal, instead of expanding linearly, it will bend. Alright, so we have discussed this in the previous topic that you can go and see. So as of now, because of heat, the biometric strip bends and it goes and touches this contact. So as soon as this contact touches, the biometric strip touches this contact, the circuit becomes completed and the bell starts ringing. So this is how an automatic fire alarm works. It works by the switching mechanism. This biometric strip acts as a switching mechanism. Okay, there are also other uses of biometric strip. It is used even in automatic electric irons. Okay, when you press your clothes, you must have seen, if it is an automatic iron box, it becomes off and on and off by itself. So there also, because of heat, there are biometric strips and there is point of contact. So when the iron box becomes heated too much, then it expands and offs the switch. Again, when it cools down, when it expands, it bends, touches, and the switch is off. When it cools down, the iron box cools down, the biometric strip also cools down, and then it breaks the contact and the switch comes on and off by itself. So like that, our automatic fire alarm works. Okay, now here is given two illustration of cubical expansion in liquids. Cubical expansion means expansion in the volume, in length, breadth and height together. So we will discuss this one first. Now this, as you can see, consists of a liquid. It can be water and some color is mixed with it, because water is colorless. So in order to see the movement of water, we need some color in water so that we can actually see properly any movement or any rise or fall in water level. So for that we make this liquid color, some pink color or some potassium permanganate we can pour in this one. There are potassium permanganate crystals, there purplish pinkish color. It will make the water color. So you can actually see the level of water. Wherever the level of water is, it can be seen clearly. So now you can see that this container is fixed on two supporters or two blocks. It can be blocks of wood, on top of which this container full of colored water. This colored water container is sealed with a cork in which a hole is drilled through which a pipe is put. There is a cork in which there is a hole, and through that hole a glass pipe is inserted, as you can see in the picture. Now this glass pipe, as of now, in this level, there is no water in it. There is no water in it. No fire is burning. This is burner. This burner is connected to gas source. Like how you have gas cylinders, like that this burner is also connected with gas cylinder. So right now no fire is burning in this one. Now let's see what will happen if you start burning this burner. So this burner will start to heat up this colored water which is inside this container. And this water, after it is heated for say 10 minutes, after 10 minutes you will see that some water has risen up through this pipe. As you can see here, I have given the diagram. Some water has risen up through this pipe. Actually, no water was there when there was no fire in this pipe. But gradually, as the water starts to heat up, it expands. But there is no more space in this container itself to hold this water. So the water which is expanding, it needs fresh space. So that fresh space is taken up inside the column which is in the pipe. So water starts rising up through this pipe and it rises up. If you heat it further, there will come a point when the water will rise up and start spilling out of the pipe. So this fact proves that when you heat water or any liquid, water expands in its volume, and this is one of the illustrations of cubical expansion in liquid. Now there is another explanation or another experiment in which 1, 2, 3, 4 different kinds of liquids are being used. You can see water, ether, benzene and alcohol, 3 different liquids. Let me explain to you the arrangement. This thing down here is a water bath. This is a water bath. Without these 3 liquid round bottom flask, this water bath would look like this. Okay, this would look like this. This is the container of the water bath. Here, water is put. So down here, you can see the level of water. Water is put over here, and not just plain water, hot water. So this water is made to heat up. So actually what water is present here is actually hot water. So this is actually hot water bath. In this they have put 4 different round bottom flasks. These are round bottom flasks made up of glass, You can see inside what is happening. That's why it's made up of glass. Alright. In this, we put these round bottom glass one by one. In which equal amounts of liquids have to be taken initially. Okay, in the beginning, initially we have taken equal volumes of water in it. See, initially there were equal amounts of water in it. This is the support to hold. Now, as you put these four containers containing four different liquids in this hot water bath, these liquids will start to expand and rise up. Like how liquid used to rise up here. Just like that in this also, initially all four of them had same level, but when it gets heated inside the water bath, these liquids expand, but they will not expand in the same manner. Some liquids will expand more, some liquids will expand less. Alright. So as you can see, after a while, say after 10 minutes, you will see all these four liquids expanding to different levels. The expansion can be seen by the rise up in the level of water. So water has expanded till here. Okay, initially it was till here. Water expands till here. Ether has expanded the maximum, as you can see. Benzene, little bit lesser than ether. Alcohol, little bit less than benzene. In other words, all these four liquids expand in different proportions. So, cubical expansion happens in all liquids, but not in the same proportion. Some expand more and some expand less. So, this is what is proved in this experiment, that different liquids expand by different amounts. Not all liquids expand by same amount. Like for metals also we had discussed, remember? Some metals expand more than the other metals. That principle has been used in bimetallic strip. Right? So here also we find that in liquids, different liquids expand differently to the same amount of